So welcome back, everybody. This is our fourth and last session of our summer lecture, KAS summer lecture on UV astronomy by Kyle Cook from UFL. And with this said, we'll give it over to Kyle, who will talk today about the future of UV astronomy, if there's a future, given the budget cuts, right? So
Right.
we'll see.
Yeah. So, there's yeah. That's a whole additional conversation. But yeah, as he said, this is the last one. We kept it to, or I chose to keep it to four lectures. Past years, I think Alan last time did like seven or eight. Kept it a little bit smaller. And I think there's good and bad in that. But I'll actually talk about that a little bit at the end. So we'll go right in to the final week. Hang on, this isn't quite what I wanted it to be. You would like to see the slides and not everything else, I imagine. There we go. Okay. So yeah, last week, so the idea is, hopefully we've kind of covered that history, the science, some instrumentation stuff, and starting to move into, so where does that all take us? What does the future look like? And the future kind of right now looks like mainly three different main missions. I put AstroSat on here, though, as we will see, it is not quite a future mission. It is already flying. But AstroSat, the Ultraviolet Explorer, and Habitable Worlds Observatory. So we'll kind of walk through these three observatories today, and kind of see where we're going. So first thing, AstroSat. I could not help sharing this absolutely ridiculous image with you all because I saw it and I just chuckled because clearly this is to scale. It was just off the Mashable website. I don't know why I got so many chuckles out of this. And to the best of my knowledge, that satellite, that is not even AstroSat. Every other image of AstroSat I have seen looks quite different. The solar panel array is different. So I think this from Mashable story on AstroSat is just wrong in every sense. And that ginormous rocket is, I don't know, I got quite a few chuckles out of it. So I thought I would share. Um, but AstroSat itself is India's first multi-wavelength observatory. So this is their space agency that launched this in September 2015, and it covers pretty much the whole range from X-ray to optical. So this is kind of, actually not kind of, yeah, I believe this right now is our only far UV view on the universe. Um, the kind of caveat on that, all these comments, kind of everything we've talked about is not including the sun because we do have things looking at the sun. But outside our solar system, I think this is the only thing right now that has far UV capabilities. Um, it is way beyond its original 2-year mission, as a lot of our observatories do. They go far beyond what they were originally planned to. It is still operating today, and it has done really, really interesting, exciting things. Though, since this is an existing mission, I don't want to spend a whole lot of time here because I'd rather, in a talk that's about the future of UV astronomy, I do kind of want to focus on the future. But this is a really important mission that I think may be a little overlooked, actually. It has a really cool way, actually, of observing the UV. So it does similar to Galax. It has a near UV filter, it has a far UV filter, and it does simultaneous imaging with essentially two different telescopes, and they've got their own, filter wheels, detectors, and everything here at the bottom. So you point at a source, you open them both up, you observe at the same time. Other missions do this as well, but kind of this like dual telescope design instead of breaking the light into two different bands is interesting. Um, like I said, it is in operation now. There is a paper on the AstroSat deep fields the Saha 24 paper. And they also have a data archive. So you can go to the Indian Space Research Organization, go to their data archive, and pull astrosat data down yourself to work with and do cool things with. Um, Couple things, it has this instrument has worked with like LIGO for gravitational wave detections to try and determine, is this optical signal optical or X-ray signal corresponding with the gravitational waves that we're seeing. It's actually caught a detection of merging neutron stars. So this has done really, really, really cool science and is continuing to do cool science. So just kind of a throw out there to keep this mission in mind if you ever need UV data, because it is there. Um, like I said, though, I don't want to spend a ton of time on it, so I want to jump into oh, sorry. First this. And sorry, this isn't showing. There's supposed to be a header right here that says Explorer class, and I'm not sure where that went. But kind of a note on NASA missions where you have overall two different classes of missions, and these are not the only two classes of missions, but you have on the left the Explorer class and then flagship missions. So your Explorer class missions are then broken down into further smaller classes, including small class missions, and medium class missions. Ironically, Galax, which did incredible stuff, was a small class mission. So small class should not be frowned upon just because it's got the term small in it. It just means you have to do really exciting things with a relatively modest budget. Um, mod Modest budget meaning in terms of designing a brand new instrument, strapping it on a missile and shooting it into space. So small class missions cannot exceed $120 million. Medium class can go up to 200 million, and these include missions like
No,
Swift.
I can correct you there. It's 300 some million, 300 million.
Oh, okay. I pulled that off NASA's website, so maybe they have updated that since they updated the page I looked at.
Mm-hmm. Yeah.
So,
It's
okay.
and by the way, a SMAX mission, another important SMAX mission is New Star.
Yes. Yeah. I I saw those and I was kind of picking which ones to list, and in the case of the SMEX missions, I just decided to go with Galax since that's one we had talked about. But on the medium class, I figured Fuse, we kind of briefly mentioned. WISE is probably one everybody knows. And WMAP, if you're not familiar with WMAP, that is absolutely a mission that you should be aware of, even though it's not a UV. Um, so as Dirk corrects me, maybe these numbers that I pulled are no longer accurate. Thank you, NASA, for keeping your websites up to date. But yeah, so but the point is these are um, kind of capped missions in terms of how much money that you can spend. Flagship missions operate a little bit differently, where flagship missions technically now are large strategic science missions, though you see the term flagship used all the time. Um, and they start by saying, what do we need to do the science we want to do? And you kind of consider that without a budget cap. So you're not looking at this is how much money you can spend. You're looking at what do you need? The big caveat, as I put here, is this does not mean you can return to NASA with well, we just need $50 trillion for this instrument, right? They will tell you no. So it's not just because there's no budget cap doesn't mean you can spend all the money you want. It just means you get to design the mission without staring at the dollar signs first. This is also why, if you look in kind of the history of some missions, sometimes you see missions with these really, really great ideas that kind of get cut back in the process. It's because the money does still matter, and at some point, you do have to start making those decisions on what you're going to include. But you do get a lot of your big, incredibly well-known NASA missions out of this. Hubble, James Webb. the Compton Gamma Ray Compton Gamma Ray Observatory, the Chandra X-ray, and Roman is technically the next flagship mission. You do hear HWO referred to as the next flagship, and that's largely because Roman is pretty much ready to launch. Um, so kind of the shift, the gaze of what's next has moved a little bit, but Roman technically hasn't launched yet, so I think we don't want to overlook that mission and keep in mind that technically Roman is our next flagship to launch. So UVEX, oh, somehow that got animated. I wasn't expecting that. Okay. I've got some weird animation stuff going on here. Okay. So and how these go about. So, Explorer missions kind of start with NASA putting something out to the community and saying, hey, we have an announcement of opportunity. It's called Send Us Your Proposals. And people draft proposals. It's very PI driven. And then once PIs around the community write their ideas up and what they want and what they could do and their kind of design, then it goes through a review process and one is chosen to be the next Explorer mission. Flagship missions tend to work kind of the other way, where, especially with something like HWO, as we'll see, you establish a science need as a community and then request that NASA do this giant mission. And NASA tends to, take those, and we'll talk about that process a touch more in a moment. So, um, I do not know what is happening with this. I'm sorry, guys. There we go. The Ultraviolet Explorer mission. First thing, as a cautionary tale, if you ever find yourself naming a mission, this is the hardest mission to look up online. If you look for UVEX, you will get the safety glasses company, the safety goggles company. And if you look for the Ultraviolet Explorer, you will get the International Ultraviolet Explorer. So it is not the easiest one to Google. Um, but it is out there. It is a incredible mission, actually. The paper is by Kulkarni, 2023. If you have any interest in UV astronomy, I highly recommend looking at this paper. Um, and these are from that original paper, the parameters that were listed. Now, this is a good point to kind of make a statement here, both about UVEX and habitable worlds as we look at it. These are missions that are in the planning and design and building phase. So what you see at one time, you may go to another paper, another website, and see things that are different because decisions are being made. And while the mission stays kind of true at heart, sometimes parameters and properties change a little bit. So you can see different things. But from the proposal paper in 2023, these are the mission parameters that were listed, and I could put a few from Galax to the side to compare. Um, because I think of UVEX kind of as the next iteration of Galax. It works in a similar way in it observes in the same wavelength, so you basically have a far UV and near UV filter. You do see some differences in the wavelength ranges, but pretty much we're in the same wavelength ranges. It has a much larger field of view. It has an improved resolution. It has a spectrograph that's going to do better in things like crowded fields. Grism spectroscopy can do really great things. It is not great in crowded fields, but UVEX will have a long slit, and you can vary that slit length to do different science cases. So like I said, I think of this as the next iteration of Galax. Uh, and this is kind of its proposed depth. So the main things I want to point out here is this was the Galax depth compared to the UVEX depth, pushing down here to let's just call it 26, but a little bit fainter than 26 magnitude. And as this mentions here, remember a change of 5 in magnitude is 100 times fainter if you're going that direction. So it will be able to observe objects greater than 100 times fainter than Galax was able to. This automatically changes our view of the ultraviolet sky. The other fun thing to point out is the circles and how much they are filled is the sky coverage. So we just had Ruben come online. Ruben will go a lot deeper, but can only see the southern hemisphere sky. No surprise there. UVEX will be able to observe the entire sky, also meaning it will fill in this about a third of the sky that Galax was not able to see. So, um, better resolution, much deeper, and see the entire sky. And another big change from Galax, if you have, say, you have a supernova go off and you want to look at this, because of course you do, right? This is where over here, the TOO, the target of opportunity, something happens that we weren't expecting, didn't know, we see it, we kind of turn all of our instruments over to look at it. Galax could not respond to this very quickly. In Kulkarni's paper, I think he actually states it could take Galax a week or more to actually respond to a target of opportunity. At this point, you've kind of missed a lot of the main event. UVEX can respond in about 3 hours. So that is a significant improvement. So if you have that supernova go off and you want to get your UV information at basically the moment of explosion, you can get there pretty quickly. Um, and the other things with it, it is kind of taking some of the technology we talked about last time. If you remember, we said that Galax used that multi-plate channel or sorry, multi-channel plate to make a cascade of electrons to observe from a photon strike. UVEX will use your solid state detectors, your CCDs. Back illuminated CCDs weren't a thing yet, so now it's going to use a back illuminated CCD, use some of the modern filter coatings that we've talked about to prevent degradation over time and just overall get a higher sensitivity and higher resolution. UVEX will focus on these three science pillars. They refer to them as. One is exploring the low mass galaxy frontier. So there's actually a cool figure on the next slide. But here's the interesting thing, right? It is easy to see large galaxies. You can see them far away, they're bright, you can see a lot about large galaxies, but most of our galaxies are not Milky Way or Andromeda size. They are much smaller than that. But small things are hard to find, especially at distance. This is one of the things that Galaxy is going to do, is to try and fill in this low mass galaxy frontier. It is also planning to focus on low metallicity. So what these do in the near universe is the idea is that they kind of serve these low mass, low metallicity galaxies serve as kind of early analogs for a younger universe. So we can kind of see what's happening in there. Um, it's also looking like it's new views on the dynamic universe. So this is a lot of your merging neutron stars. A lot of the cases it can do working with gravitational wave detectors and things of that nature. So kind of your changing, exploding dynamic universe. And then I started this week one by telling a couple stories on my experiences trying to find an all sky UV image and how that ended in bitter disappointment. So UVEX wants to add that UV all sky survey that will provide the really only good UV counterpart to all these other all sky surveys that we have. So this should be a massive increase in the amount of science that we can do and the amount of detections that we have. And this is the figure I mentioned on the discovery space, specifically for the low mass and low metallicity. So the orange dots are the UV, or sorry, Hubble observations, what Hubble's been able to observe. These are the blue squares are known UVEX targets, so things we already know exist that UVEX will be good for observing. And then basically this big empty space is where UVEX hopes to fill in a lot of detections. So very low metallicity, young populations to try and, like I said, look at those as analogs of the early universe. But this is why I mentioned I highly recommend if you have an interest in UV astronomy, go to this. The proposal paper is 69 pages long, and roughly half of that is not even on what UVEX, not on the UVEX science pillars, but are on all the other science cases that UVEX can help inform. So if you build this instrument, is basically what was being said at the time, then go in, we can make this data public, and these are the other types of science cases that can be done. So if you want to know what can you do with UV astronomy beyond the cases that I talked about, this is a great place to go and get an overview of those topics. That is currently published. Um, Currently expected launch is 2030, so fingers crossed on that. As Dirk mentioned, the world is a fun place right now, and even in the best of cases, missions often don't launch on time, but fingers crossed for 2030. So, finishing up with UVEX, I want to take a moment to mention the decadal survey because I think it's actually very important to say out loud that as astronomers, we should be very grateful that astronomy is so community based and that we are asked for our opinion by kind of the powers that be, because not all fields are like that. So astronomy is one of those fields that every 10 years we do what's called a decadal survey. Some of you are very aware of this, others may not be. But basically, what the decadal survey is all the astronomers who want to can write white papers, and then a committee will go through and dig through all these white papers and all these science cases and everything that the community thinks is important for the next 10 years of astronomy and compile it into one massive document, one massive book, actually, really. So Astro 2020 is the latest decadal survey. And this quote from it is the birth of Habitable Worlds Observatory, where basically the survey recommends that the first mission to enter the Great Observatory's mission and maturation program is a large 6-meter infrared optical ultraviolet space telescope. So this is kind of that seed on, as a community, this is what we need. So then NASA picks that up and says, okay, our next great observatory will be a 6-meter infrared optical ultraviolet telescope, which takes us to Habitable Worlds Observatory. And these are three proposed designs for habitable worlds. These are all things to be tested, things to be looked at. You see, they all use segmented mirrors. You have kind of your James Webb design, you have other designs that are being looked at. Um, it is worth noting, whatever habitable worlds ends up being, it will not be any one of these three things. Each one of these designs will have strengths, will have weaknesses, will have areas they were really good and areas that they were really bad. And kind of the good will be picked, the bad will be left behind, and the eventual HWO will be some conglomeration of these three things and possibly others. Um, so the plan for HWO is to launch in the 2040s. Again, we will see how this goes. Um, James Webb was massively past time. Rubin Observatory's deadline, even though it's not space-based, got pushed out many, many times. This is what happens when you deal with creating new technology. Because one of the benchmarks for great observatories is not to find answers to our questions, which is part of it. But part of or not, I'm sorry, I said a great observatory, a flagship mission. A large part of a flagship mission is designed around finding the new questions to ask, to find the things that we don't know about yet. So that's kind of one of the big things with a flagship mission, and it involves new technology, new ideas. Um, all this to be said, I want to reiterate the caveat I said before on perhaps these three designs have changed since I saw this presented by the, planning committee for HWO. There is a meeting in DC at the end of July that I will be at, so it is quite possible I walk out of that meeting with entirely new ideas and concepts of what HWO is now, because it is an active development. So things can change rapidly. But to the best of my knowledge, this is the most current, or most current released, let me say. So HWO focuses on three science cases. One is our dynamic solar system. So it is designed to look at solar system objects and really fill in some of our gaps in knowledge there. Its namesake comes from the idea of exotic worlds. Um, one comment made in some of these HWO missions is we may know if there is other life in the universe within our lifetime based on the science that HWO does. That is a large part of what it is. So one of HWO's goals is to detect about, I think the last number I saw, about 25 habitable worlds. 25 isn't a huge number, but these are worlds that we have confirmed could support life. And the hope would be, at least one that we actually detect definitive biosignatures on. And then the third is transformative astrophysics. And this is kind of the spot I was talking about before, where this is where the things we don't know live. So it always kind of gets a little bit of a giggle out of me when you see all these news stories about James Webb, where it's James Webb discovers incredibly old galaxy that baffles astronomers and everything else. And it's like, okay, yes, but that was kind of the plan. Like the plan was to find things that we didn't understand on first look. So this is just James Webb is doing exactly what it's supposed to in that transformative astrophysics part of its mission. These are, again, last that I am aware. I put the date that I got this, October 24th, 24. The HWO instruments. I will say, I think these are changing in some ways. Obviously, you have the telescope. This coronagraph is being tested on Roman Observatory itself. So part of Roman Observatory is to test a coronagraph to block out light, to detect close-in planets as a technology demonstration for HWO to prove that the concept works. A high-resolution imager, so UV, visual, and visible and near IR, and a multi-object spectrograph, again, UV and visual light. So this, for instance, this bandpass, the number I'm seeing now is going down to 100. I am on a working group to determine how far that 2,500 needs to go. Is 2,500 sufficient? Do we need to go further out? Um, and there is a lot of push to go shorter than 100 in a lot of the science cases. So I think this number has already changed. And if it hasn't been decided to be wider than that, it is absolutely being heavily considered. So we will see. This one does go down to 100, but there have been requests for imaging down to 100 as well. And then the plan for HWO is basically for a fourth box right here for a fourth instrument that, as of this point, has not been determined. So if anybody has a great instrument that you would like to see on HWO, this is your time to speak. Um, but this is the status as I am aware of it now. And some of the ideas and plans here. So this unprecedented resolution. So you can see on your y-axis what your resolution in arc seconds would be. You can see this is where Hubble lives. You can see this line for James Webb, and you see HWO pushing down much further than those, but even further than massive ground-based telescopes planned, like the ELT. And then you have like ALMA and stuff, but we're in a completely different wavelength range here. So much higher resolution. And this incredible image, which is a simulation, of course, of what a redshift 2 1 million solar mass galaxy looks like in Hubble at 30th magnitude versus what we expect to be able to get with HWO. So these are obviously nowhere near each other, right? Hubble is an incredible instrument that has done incredible science for a very long time. But when you look at this compared to this, we are in completely different classes on what we're telling. And the idea here is at a redshift of 2 in a 30th magnitude object that we can resolve stellar populations. So let me say that a different way. At about half the age of the universe, fainter than most things can see now, we would be able to resolve stellar populations. That is the goal for HWO. And I want to wrap up with ideas on involvement and how one gets involved. And I'm speaking mostly to students here, which does include myself, on how you can get involved instead of just sitting back and reading the stories and the great things that are happening, but how can you become a part of it? So, one is HWO has a Slack channel that you can go to this link, to this QR code, and just sign up for permission to join the Slack channel. One great example on why this is right before this started, I got an email. I'm on this Slack channel, and Courtney Dressing put out a paper that I used some things from for this seminar that hasn't been published yet. And she's like, hey, anybody who wants to be a co-author on this paper, sign up and send me some feedback and things like that. And now there's, direct Zoom meetings and things that are going to occur for, comments on the paper. Let's talk the paper over and stuff. And this is absolutely something I'm going to do. And this is just, I wouldn't have never known about it if I wasn't just sitting in this Slack channel. So small things can make big differences. Um, HWO's been doing a seminar series, so if you just kind of want to keep up with it and what's going on, this is a link and QR code to where you can go see the schedule as new things are announced. There's nothing future on it right now. The next thing is the meeting in DC, and then also just their mailing list. You can go sign up for that as well, so you get regular emails. So that's my ideas of involvement for HWO. But more general, NASA has what they call the Cosmic Pathfinders missions. This, if you sign up, you just get an email when they send one out. It's not every day, it's not every week. It's just you kind of get them when you get them. But they are fairly regular, and there's all the information they send in other email lists, like proposals open and things like that, come through on the Cosmic Pathfinders as well. But they do also try to do different kind of student get-together groups and virtual meetings and things like that. And since we keep dancing around kind of the politics of everything, the um, oh my God, I'm blanking on that acronym. Institute of Physics, the American Institute of Physics. They have a newsletter, FYI, where you kind of get updates on what's going on, what policies are being decided, and things like that. And just getting that and kind of getting a little bit of news very relevant to what we do without the inflammation that you see on like social media and even on a lot of news stations and channels is good. It kind of gets straight to the heart and straight to the fact. This is what's happening, and this is the effect of that. So these are great places to go. And then my wrap up. Um, I want to emphasize again that as astronomers, as the astronomical community, we actually have a lot of really good things that people have built. Um, ADS is an incredible thing that a lot of fields don't have, but just the idea that, NASA ask us what we need and ask for our input. And the more you kind of join some of these groups that I mentioned, the more you can see how NASA asks for feedback. Is we should be very, very lucky and very grateful for that. Um, I also, just in that, ways to get involved, it is never too early to start networking, and networking is a huge bit of your future success. The more people you know, the more people that recognize your name, is great. I will tell you when I review the archive in the morning, sometimes, I look at titles and things that I think are going to be interesting. Of course, I also kind of look at people's names because I'm like, oh, I know that person. I know they do good work. I'm curious what they're doing, or I met them at a conference, or, maybe I used to go to school with them or something else. And it's, kind of fun to keep track of people you know. Um, so, find those Slack channels, talk to people, get those newsletters. When opportunities come out, get involved and talk. And most astronomy people, there are exceptions, but most astronomy people are pretty very calm, cool, and interested to get messages from people. So I have absolutely messaged people in these Slack channels. Courtney Dressing, who's doing that HWO paper. I was like, wow, there's really cool stuff in here, but this isn't released. Well, I'll just message her and ask her permission to use these things. And we struck up a conversation about what's going on. And now I know this person. I'm going to go see that person at a conference, and it'll be great to put a name to a face to talk. And then we know each other. And then that's, just a little bit. And then it's always good to stay up to date on what's going on, stay knowledgeable of what's happening, but especially in times like this, where funding is at risk, where there's so much uncertainty around everything, understanding what's going on will help you position yourself better. Um, so the ultimate takeaway, my goal here was to convince you all that UV astronomy is not only interesting, but that there is a huge range of what can be done, both in the science and in the instrumentation, and to see what's coming and what's going in ways that you can incorporate these new things into your future. And that's actually kind of one of the big points, and that's why you hear me say HWO so much, while where we do have great missions like UVEX. Um, Now is the time to get involved with something like HWO. Now is the time to say, I want to make an impact on this. We're still deciding what this thing looks like. This is the time to get in, to work with people, to develop yourself, because this is a mission that you can follow through your astronomical career and hopefully be really excited about. So I will stop there and take any questions we may have.
Super. Thank you, Kyle. So, questions for Kyle.
I know I saw a few things happening in the chat. I don't know if any of that was for me. Okay.
But
Questions
I
there.
mean, thank you so much for doing this, because this was really great. I mean, pulling this together, giving us, overview about instrumentation, what are the sources out there, and then not just saying, okay, yeah, this is what we did in the past, but also look into the future, because there's a future for UV astronomy with
Yeah,
UVEX, in particular with UVEX coming up.
yeah.
I mean, UVEX is really on the horizon because it's what you said is 5 years down the road, maybe six. But it's coming up fast. I mean, habitable world, mid 2040s, okay. Things will
Mhm.
definitely change by now, but UVEX
Yeah.
is really out there.
Yeah, UVEX will give a huge amount of data that will be great for everybody sitting here to be able to use. Like I said, the reason I tend to focus on HWO is it's still early enough to influence. Um,
Mhm.
UVEX is, we're not going to change much on UVEX at this point.
No, and the other thing is UVEX is also different, right? Is what you said. I mean, when you have a mid-X mission is built for a specific purpose. And for UVEX, it was these low metallicity, low mass galaxies, and what you said also the survey, right? The
Mhm.
doing the UV survey. But it's not like, habitable worlds, which could be anything by now. It's a legacy observatory, which has a different purpose. It's more a general purpose observatory than it is like some build something for a specific question. Now,
Right.
can this mission devolve into something else? Of course it can. I mean, look at Swift, right? Swift was built as a gamma ray burst observatory and now does everything else except for gamma ray bursts. Well, they still do
Right.
10% gamma ray bursts, but most of the time they do TOOs um, and monitoring
Spencer's another great
observations.
example of a observatory that had its mission changed
Yes,
a lot.
correct. And very successfully did this.
Hmm.
Um, so I mean, UVEX can evolve in something, but if you have a mid-X or a SMAX mission, they always focus on some specific topic, and that's why they built the mission around it,
Right.
which is different to the flagship missions.
Yeah. And it is worth saying, especially if any of these links were interesting to you, this will be hosted on the KAAS website, so you can go pull these slides. If at any point you're like, didn't somebody mention something about a place I can do this? These will be available there. And I think my other kind of caveat on this entire thing is, keep in mind that this is a huge field in itself, so that this is an overview of UV astronomy, both in
Hmm.
science cases and in instrumentation. I could have easily done, I could have taken 8 science cases and done a week each on just those. So, it is very much an overview, and there is a lot of good information out there. So, and like
Hmm.
I said, I think at this point, I would recommend Kulkarni's UVEX paper because he does do so many of the science cases there. We'll see a lot more of that when Courtney Dressing's paper comes out, but it's not out yet, so I can't direct you to that. So,
Hmm. Okay. Well, thank you very much, Carl, again. Any final remarks from anybody? Okay. Then this will be, again, what you said, will be posted together with your slides, apparently, right? As
yes.
well. So if you need the QR codes, they will be in the slides as well. Thank you so much, Kyle, for doing this stepping forward. When we had our KS meeting in April saying, yes, I can do it. I talk about UV astronomy and boom, here we are. And 3 weeks later, we're done. Time
Yep.
flies. Okay, well, thank you so much. I think
Thank
I
you.
can stop the recording now. And again, this will be posted. Thank you, everybody, for attending. And thank you, Kyle, for doing this year. Thank you so
Yes, and
much.
thank all of you all for being here.